are continuing from question number 14 of NCERT Class 11 Mathematics, Exercise 3.3. In question number 14, we have to prove that sin 2x plus 2 sin 4x plus sin 6x is equal to 4 cos square x multiplied by sin 4x. Now, in proofs always we look at the RHS what we need. In this case we need sin 4x and we also need cos square x. So sin 4x must be maintained on the left hand side. So I am writing LHS and arranging it such as is equal to sin 6x plus sin 2x plus 2 times sin 4x. Now I am applying formula of sin A plus sin B on sin 6x plus sin 2x. Now sin A plus sin B, we know that is equal to 2 sin A plus B by 2 multiplied by cos A minus B by 2. So it becomes 2 sin A plus B by 2. So A plus B by 2 means our A is 6x plus 2x by 2. Similarly, cos A minus B by 2, so it becomes 6x minus 2x by 2, and on the last part it is 2 sin 4x. Now solving this we get it is equal to 2 sin. Now 6x plus 2x is equal to 8x. 8x by 2 means it becomes 4x multiplied by similarly cos 6x minus 2x is 4x. 4x by 2 is 2x and plus 2 sin 4x. Now from both the terms I will take common 2 sin 4x and it remains cos 2x plus 1. One requirement is fulfilled, that is sin 4x. Now I will apply a formula of cos 2x in which there must be cos square x. So there is a formula of cos 2x h. Cos 2x is equal to 2 cos square x minus 1. So I am putting that formula 2 cos square x minus 1. Now plus 1, because plus 1 is there in the expression, is plus 1 and I am closing the bracket. Now it becomes 2 sin 4x and it is multiplied by minus 1 plus 1 cancel out, it becomes 2 cos square x. Finally it comes out 2 into 2 4 cos square x multiplied by sin 4x, and this is our RHS and proved. Okay, next question number 15. We go to question number 15. In question number 15 it is given as cot 4x multiplied by sin 5x plus sin 3x is equal to cot x multiplied by sin 5x minus sin 3x. I am taking the LHS and the LHS part is this one, and I will again put the formula of sin A plus sin B on it is equal to cot 4x. Now sin A plus sin B, again the formula 2 sin A plus B by 2, that means it becomes 5x plus 3x by 2, sorry, That must be here 3x by 2 and multiplied by cos a minus b by 2, that is 5x minus 3x by 2. Total bracket closed. That becomes cot 4x, and this multiplication, so you can avoid the bracket 2, and it becomes sine 5x plus 3x means 8x by 2, so it becomes sine 4x, which is multiplied by cos 5x minus 3x is 2x by 2, that means x. Now cot 4x can be written as cos 4x by sin 4x. So it can be written as cos 4x by sin 4x, because I want to cancel the sin 4x. So here it is sin 4x multiplied by cos x. There is a 2, I have missed the 2 is here. Okay, sin 4x cancels out, and in the end what we get is this one, that is 2 cos 4x multiplied by cos x. Now we can apply formula of 2 cos A into cos B, 2 cos A into cos B. But if we apply 2 cos A into cos B, then we will get what? In this question, our requirement is different. We have on the RHS, we have also a cot x multiplied by sin 5x minus sin 3x. So if we solve both the equations, then we could get the answer very easily. So hence I am naming this equation as equation number 1, LHS as equation number 1. Now I am going to RHS part. RHS is equal to cot x bracket sin 5x minus sin 3x. Again applying the formula. Now it is cot x of sin A minus sin B. It becomes 2 cos a minus b by 2. Sorry, a plus b by 2. That means 5x plus 3x by 2 multiplied by sin a minus b by 2, and it becomes sin 5x minus 3x by 2. Overall bracket closed. That becomes is equal to cot x. Now cot x I should write it as cos x by sin x. It can be written as cos x by sin x. Again multiplied by, it becomes 2. Now cos 5x plus 3x is equal to cot 8x by 2. That means it becomes cos 4x. Again multiplied by, it is sin x. Now sin x cancel out, and it remains 2 cos 4x multiplied by cos x. Okay. Now if this becomes equation number 2. Now equation 1 and 2 both are equal. From 1 and 2 we get LHS is equal to RHS and both. Now we go to question number 16. Question number 16. Okay. It is a question of fraction cos 9x minus cos 5x by sin 17x minus sine 3x is equal to minus sine 2x by cos 10x. This is the LHS and RHS part. Again I am taking the LHS part and start solving it as control C. Here it is LHS is equal to, now I am applying formula both on the numerator and denominator. In the numerator I have cos A minus cos B, and cos A minus cos B is minus 2 sine A plus B by 2 and sine A minus B by 2. Now first I write the expression, then I will put the values. First I am writing just the expressions. Okay, minus 2 sine A plus B by 2, it is 9x plus 5x by 2, and the other one is sine 9x minus 5x by 2. In the denominator side there is a formula of sine A minus sine B. Sine A minus sine B is 2 cos A plus B by 2 multiplied by sine A minus B by 2. Okay, and here A is 17x plus 3x by 2, and we have 17x minus 3x by 2. Okay, we will finalize it. 2 and 2 cancel out. We have a negative sign on the upper side, so it is negative. I'll putting this negative sign inside a bracket. Now it becomes sine 9x plus 5x, 14x by 2, that means sine 7x, and again it is sine 9x plus 5x is 4x by 2 is 2x cos 17x plus 3x is equal to 20x by 2 means cos 10x multiplied by sine 14x by 2 7x. Now sine 7x and sine 7x cancel out, and it becomes minus sine 2x, and it becomes minus sine 2x by cos 10x, and this is our cos 10x, and this is our RHS. This is equal to RHS, and proved. This is proved. Now question number 17. Question number 17 is a similar question. It can be done in the similar manner. Okay, I am showing it. Okay, now you go to the question. The question is written as sine 5x plus sine 3x. In the numerator is sine 5x plus sine 3x, and in the denominator which is cos 5x plus cos 3x, and we have to prove it as tan 4x. I am taking the LHS again, LHS part. Is equal to applying again the same formula of sine A is plus B and cos A plus B. In the numerator part it becomes 2 sine A plus B by 2 and cos A minus B by 2, and the I am putting the values. It is 5x plus 3x by 2, and it is again 5x plus 3x, so it is minus 3x, 5x minus 3x by 2. In the denominator side, it is cos a plus cos b. Cos a plus cos b is equal to 2 cos a plus b by 2, and again cos a minus b by 2. So it will become 2 cos 5x plus 3x by 2 and cos 5x minus 3x by 2. Now 2 and 2 cancel out, and in the numerator, that is sin 5x plus 3x by 2 means sin 4x multiplied by cos 5x minus 3x is 2x by 2x. In the denominator, it is cos, again it is 4x and multiplied by cos x. Now cos x and cos x cancels out, and we get sin 4x by cos 4x, and then we know that it is tan 4x, and that is our RHS part, and we have proved it. Now we go to question number 18. Question number 18 is also a similar question. I am writing it: sin x minus sin y by cos x plus cos y, cos x plus cos y is equal to tan x minus y by 2. That we have to prove. Cos x minus y by 2. Now I am taking the LHS part again and applying the formula. LHS is equal to, now applying the formula once again, just scrolling the screen. Okay. On the numerator part, it is sin a minus sin b, and sin a minus sin b is equal to 2 cos a plus b by 2 and sin a minus b by 2. That becomes x plus y by 2 and x minus y by 2. In the denominator side, this cos a plus cos b, that becomes 2 cos a plus b by 2 and cos a minus b by 2, cos a minus b by 2. Now putting the values, it is x plus y by 2 and cos x minus y by 2. Now 2 to cancel out, and cos x plus y by 2 and cos x plus y by 2 cancel out. Now it remains only sin x minus y by 2, it is x minus y by 2 and cos only x minus y by 2, x minus y by 2. And we know that cos sin a by cos a is equal to tan a. It becomes tan x minus y by 2, and this is our RHS. This is equal to RHS and proved. Now we go to question number 19. Question number 19 is a similar question. Again, the numerator and denominator question. It is sin x plus sin 3x by cos x plus cos 3x. Cos x plus cos 3x. And that is equal to tan 2x. It is equal to tan 2x. I am again taking the LHS. All questions in the same pattern. So it is very easy exercise. LHS is equal to, again equal, again the formula sin A plus sin B. These four formulas are very important. Sin A plus sin B, sin A minus sin B, cos A plus sin B, and cos A minus cos B. Now sin A plus B is equal to 2 sin A plus B by 2. 2 sin A plus B by 2. So, and cos A minus B by 2. Putting values, x plus 3x by 2, and in cos is x minus 3x by 2. Now cos 2 cos, again A plus B by 2, and cos A minus B by 2. Again putting values, x plus 3x by 2, and similarly here it is x minus 3x by 2. I will get h. 2 cancel out. Now it becomes sin 4x by 2, then sin 2x, and cos minus x. In the denominator it is again cos 2x and cos minus x. Now cos minus x cancel out, and we get sin x, sin 2x by cos 2x. We get sin 2x by cos 2x. And that we know it is that tan 2x. And that is our LH. It is our RHS. Sorry, it is our RHS and split. Now we go to question number 20. Question number 20. Question number 20. Okay. In question number 20, it is given as sin. Similar question. Sin x minus sin 3x by sin square x minus cos square x, and we have to prove that it is 2 sin x. I am again taking the LHS part. And starting the solution. One second. Taking the solution is equal to LHS is equal to, now applying the formula. Now sin A minus sin B is equal to, we know that 2 cos is A minus B by 2 and sin A plus B by 2. That becomes cos x plus 3x by 2 and sin becomes x minus 3x by 2. In the denominator it is sin square x minus cos square x. We know that cos square x minus sin square x is equal to cos 2x. So it is sin square x minus cos square x. It is negative of that. It is minus cos 2x. Now can be written as this. Okay, this 2. Now cos x plus 3x 4x by 2, it means it becomes cos 2x, and again it becomes sine minus x. Okay, and in the denominator it is minus cos 2x. Now cos 2x and cos 2x cancels out. One second, cancel out, and it remains only minus, and we know that, I am first writing it, there is a minus in the denominator, and I am writing it. One second, minus in the denominator means minus 1, and in the numerator cos 2x cancel out, becomes 2 into sine minus x is equal to minus sine x, so it becomes minus sine x. Now the minus of the numerator is cancelled out by the minus of the denominator, and it remains sine x, which is our 2 sine x, which is our RHS and square. This is our RHS, and we have proved it.